This is the Mechanics Homework Booklet, question 21. The diagram shows two different rifles being fired horizontally from a height of 1.5 metres above ground level. We're also told that we can assume the air resistance experienced by the bullets is negligible. Already you're probably identifying this as a projectile type question, and because of that you need to be very careful about identifying horizontal and vertical motions. So I've started a bit of colour coding for you here. Part A. When the rifle A is fired, the bullet has a horizontal velocity of 430 metres per second as it leaves the rifle. We're asked to find the time that the bullet is in the air before it hits the ground. To do this, we consider vertical motion. So here you can see that it fell a distance of 1.5 metres. The initial vertical velocity would be 0. We don't know the final velocity. The acceleration will be the acceleration due to gravity, and we want to know the time for this fall. Because we don't know v, we can select an equation that doesn't use it. So we select s equals ut plus a half at squared. With u equals 0, this simplifies nicely. So we substitute in our known values and then rearrange to give an expression for the time. I've given an answer here to two significant figures to match the minimum data we had in the question, which was the 1.5 metres. Next, we're asked to calculate the horizontal distance travelled by the bullet before it hits the ground. We have just worked out the time of flight by considering the vertical fall, and this time is common and it therefore also applies to the horizontal motion. Because we have negligible air resistance, we will have no deceleration and the acceleration is 0. This means that the equation is really just distance equals speed times time. So here we have our initial horizontal velocity, and that remains constant, multiplied by the time we calculated in the previous part of the question. When carrying forward previous answers, it's always good to keep an extra significant figure and then do any rounding at the final stage. This preserves the integrity of your answers. Finally, we have an explaining part to the question. We're told that rifle B is fired and the bullet emerges with a smaller horizontal velocity than that for bullets from rifle A. You're asked to explain why the horizontal distance travelled by bullet B will be less than bullet A. Be careful here that you don't, almost in your head, just think this is obvious. It's your job to explain the steps and the physics behind it. This question is really centred around your understanding of the independence of horizontal and vertical motion, which I've highlighted here. Now, the consequence of the independence of vertical and horizontal motion is that the vertical acceleration for both these bullets is the same. They have different initial horizontal velocities, but their initial vertical velocities are both 0 and they both have the same vertical acceleration, the acceleration due to gravity. For this reason, both bullets will fall in the air for the same length of time. So the final piece of the argument, looking back at the question, we're asked to comment on horizontal distance travelled. So that is going to equal the horizontal velocity times the time. This means that horizontal distance is in fact proportional to the horizontal velocity. And since that is less for bullet B than it is for bullet A, that will lead to a smaller horizontal distance being travelled in the time.